Okay, we're moving on. Seeing different examples, different wrinkles going to be thrown at us. We're solving trig equations. Okay, we see this one. It kind of rings a bell. It looks like a quadratic, right? 2 something squared, linear. But there's the problem here. This would be an x squared and this would be a y because they're not the same. This is a sine and this is a cosine. Luckily, we have our foldable, or we have a good memory and we know the most popular trig equation there is can convert or change sine squared into cosine squared. So we're dealing with all the same thing. We want to be all in sines or all in cosines. In this case, it's easy to change a sine squared into a cosine squared. So let's change them all into cosine. Here we go. From here, I'm going to distribute. No problem. Combine like terms. We will have a 2 times 1 and then 2 minus 3. That's where the negative 1 is. We have a negative 2 cosine squared. I personally, I don't factor if the leading coefficient is a negative. So from right here, I'm going to multiply both sides of these equations by negative 1. And that's okay. That'll change the signs on this one, and this one. If you multiply a 0 by a negative 1, you're still going to get 0. So I get this. Now we're factoring again. This is x method. This is because there's a 2 out here, right? We can draw an x. There's going to be 2 x's on top. They're actually cosine x's. Multiply the first and the last one. Middle one on bottom. 2 numbers that multiply to a positive 2 and add to a negative 3. They are a negative 2 and a negative 1. Simplify fractions. That will be a 1 over a 1. So x minus 1, or x actually cosine x minus 1. And then 2x minus 1. It's actually a 2 cosine x minus 1 equals 0. And then from there, we're going to set them both equal to 0. So there's the factoring piece. That's from an older problem. Ignore that. I'm going to set each one of those equal to 0. Add 1, divide by 2. When is cosine 1/2? The next one, add 1 to the other side. When is cosine equal to 1? Well, cosine can't be a triangle here. Cosine is the x-coordinate. When is the x-coordinate equal to 1? That's what that's saying. Well, that's at 0, or 2 pi. Okay? For this one, when is cosine 1? Cosine is positive in the first and fourth quadrant. Cosine is adjacent over hypotenuse. I'm trying to figure out what these angles are. Okay, well, that would be a 30-degree angle, so that's going to be 60 pi over 3. All the way around is 6 pi over 3. Back it up, 5 pi over 3. Okay? From here, though, in the directions, it just said solve. It doesn't say solve on the interval 0 to 2 pi. We don't have that little nugget about 0 to 2 pi. We want a general solution. So even though it didn't say, give me a general solution, that's exactly what we need here. So we need this one. There's no symmetry here either. I'm going to have this answer, and this answer. There's no symmetry about it. So I'm just going to write all of them. I'm going to write the first one, pi over 3 plus 2 pi n. Apparently I messed it up the first time. I'm glad I fixed it. 5 pi over 3 plus 2 pi n. Around the circle over and over and over. And then the other one would just be 0 plus 2 pi n, because that's 0 radians. But 0 plus 2 pi n is just 2 pi n. Okay, we listed them all. That's our general solution. Okay, that's what we're looking for. We got one more type of problem to see for this round. And then I'll give you guys your stamp and we can just keep practicing this stuff, okay? So here's the last one. The last one says to find a general solution for 2 cosine 3t minus 1 equals 0. Okay, so at first glance, hopefully we all see probably going to add 1 and divide by 2. That makes sense. We're isolating the trig part of this. Cosine 3t. We haven't had to deal with cosine 3t, okay? So what I can do is like our little calculus trick here. I'm going to do a u substitution. That 3t bothers me, but if it was just an x or if it was just a u, it wouldn't bother me as much. So I'm going to say this. I'm going to let u equal 3t. I'll take this 3t out and I'll replace it with a u. Ooh, now it doesn't bother me that much. When is cosine equal to 1/2? That's in the first and the fourth quadrant. Kind of like the last problem we just did, right? Yep. Pi over 3 and 5 pi over 3. There's no symmetry there, so we would need to add 2 pi n to each of those. But be careful here. We're not done. We don't pat ourselves on the back. We made this u substitution up here, and we're actually solving for u when we're doing all this stuff. So u equals pi over 3 plus 2 pi n, and u equals 5 pi over 3 plus 2 pi n. But that was just some fictitious variable, fake variable, dummy variable that we made up. U, we're going to do some back substitution, is actually 3t. right? So it says right here, u is 3t. So I'm going to back substitute now, and 3t is equal to that answer, and 3t is equal to that answer. How would we solve that equation? The answer, divide everything by 3. We're going to divide this side by 3, just a t. This side by 3, pi over 9. And this little chunk by 3, 2 pi over 3, n. Same thing here, divide everything by 3, and we're left with our general solution. So again, when the argument is different like that, we can do a little use substitution and make it normal for us. Go through and solve the problem as if it was normal, and then at the end, just adjust our answers based on whatever trig substitution we did. Okay? That's 5-3-2. There's still one more topic I want to talk about, but not today. Okay, I want you guys to practice these. Here's your guys' stamp. 18, 22, 24. There's some evens in there. That's okay. You're going to have to be able to do them. Bring your questions with you to class. 25 through 37, odd. 35 is different. It's new, but based on what we talked about just now on these videos, you should be able to handle it. Okay? Moving on.